Okay, you've been getting used to using binary numbers, but we're going to have a look at something called fixed point binary. Now, fixed point binary is really just when we are dealing with what we call in computing real numbers. And real numbers are really what we would just call decimal numbers. Okay, so for instance, if we've got 12.25 in base 10, you're so used to doing it, you don't really think about what you're doing. But what we would have done in the past, certainly when you're in primary school, you might have said, right, okay, hundreds, tens and units. And then you would have your point, and then you would have 1 over 10 for tenths, and you would have 1 over 100 for 100ths, and 1 over 1,000 for thousandths, and so on. Okay, so just get that into shot there. So what would we do? Well, 12.25, I've got 1 10. I've got 2 units or 2 ones, okay, which makes my 12.25. Okay, I've got 2 tens, and then I've got 5 hundredths. Okay, 12.25. So really easy, and everyone can see where that comes from. We can do exactly the same in base 2. So I'll just move that up a little bit. We're going to try and represent 12.25 in base 2. Okay, we need our binary place headers, so I'm going to put my point in as usual. 1, 2, 4, I'll just go up to 8. And now on this side of the point, because I'm working in base 2, I can say 1 over 2, 1 over 4, 1 over 8. We'll just go to 1 over 16. So I want to represent 12.25. So what I need to do to get 12, I need an 8 and a 4. It's going to give me the 12, fill in the rest with zeros. 0.25, well 0.25 is a quarter, so I can just put 1 there and fill in the rest with zeros, make sure I have my point there. So I actually get 1100.01, and that's 12.25 in denary represented in binary.